Okay, we can review. We were introduced to object-oriented programming. This programming paradigm models a domain using objects. And these objects can perform actions, and they can have actions performed on them by other code. For example, a gradebook, an object, can print grades, or a professor can record student grades. Thus, with object-oriented programming, we model a domain with objects. There are two introductory concepts in object-oriented programming. We go to a bank account example. We have a bank account class, and there may be a getBalance function, return some value. Other code, for example, an ATM object or a teller object, can communicate with bank account to get the balance via the getBalance function. There may be other code here that is irrelevant to ATM or bank teller. If ATM gets a query from a customer wanting the balance, then ATM simply needs to call getBalance, gets the value, and displays some balance for a customer. This is the concept of abstraction. ATM does not know how the getBalance gets its balance or how it is implemented. But it doesn't really care because it's getting what it needs from bank account. Now, bank account, we are modeling a real bank account in the banking domain. Thus, this is known as an abstract data type. Okay, so with code, let's see how this works. So we come here to our code, brief review, keyword class, the name of the class account, open curly brace, close curly brace, do not forget the semicolon. We have a public keyword that is an access specifier. And then we have the getBalance public function, meaning other objects can use getBalance. We go straight to main to demonstrate this. If we have an account type variable with name lowercase account, initial value 100, we can display this to screen by calling the getBalance function. Notice implicitly we are working with balance. Let's look at the code for getBalance. We go to bank account. We simply return the balance, a copy of the balance. So we are not letting other classes directly work with our private data balance. Notice we have the keyword const here, meaning we are protecting the integrity of balance. No one can modify the balance in this function because we are simply using it to return the current balance of this account. Okay, so we can go ahead and run this. So we will run the code. I'm having issues with my mouse, so I have to go find the executable here, 8, and I go ahead and run it. And then our program outputs 100. Thus we show that we can work with the getBalance public function. Okay, so we go on to the next concept, which is encapsulation. So this concept also uses the bank account class. So we have the bank account class. We have getBalance function, class function. We may have a variable, I'll use it for simplicity here, balance. And then this balance has to be initialized somehow, maybe with some private function that retrieves get begin balance from somewhere, maybe a database. Again, this is a simple example. We come back and revisit our ATM and teller classes or objects. ATM cannot directly talk to balance. We will get an error if we try to do that. ATM can also not directly communicate with getBeginBalance. However, as we showed before, ATM can get balance. So ATM does not know the details of balance or getBalance. It cannot see them. That implementation is hidden away from ATM. Thus, this concept is encapsulation, where some functions and variables are hidden from ATM. And we can demonstrate this with code. I will only demonstrate with balance, okay? So we come back to our code. We come back here. We see that balance is defined here, like we can see it here. However, there's a difference between getBalance and balance. GetBalance is in the public access specifier, meaning users of the class and the main program can use getBalance. However, private means that only the class can use this data. So we use balance here. So getBalance knows that balance exists. However, if we go to main, we cannot say account dot balance and expect our code to work. Notice the compiler code help tells us that balance is inaccessible, meaning it is private, and that's what encapsulation does. Like, we hide details from users of our class because they are irrelevant to them. Okay. Finally, we briefly cover class scope. Within the class, the class function can use class variables. For example, here getBalance knows that balance exists, and notice it knows that it is the balance that belongs to the account class. The constructor, which is a special function that allows us to initialize data, like we did here in main, can also see other functions. For example, if we say getBalance here, notice that it allows it, and it knows that it's the getBalance from account. Then we move to constructors. If we have this code and we come back over here, this will not work. Notice right away we see that C++ is telling us that there is no account that accepts a integer parameter. We just removed it. However, if I do this, then my code works. If I go ahead and run this code, notice it gives me a value of 0. So meaning we did not define a constructor. However, the constructor that C++ creates behind the scenes looks like this, a constructor that does not do much, but it allows us to create an instance of our class. We can run the code again and notice that it's 0. Okay, so if we go back and at the initial constructor, like we did here, C++ will not provide the constructor that I just demonstrated right here. It will eliminate it. It will not provide a default constructor for us, which is the name of this one, so it'll not create it for us automatically. So by doing adding line 6, then it's C++ doesn't allow that behind the scenes, so I have to define it manually. Okay, and those are the concepts that I need students to understand so that we can move forward with other class concepts. Thank you.